So this is the first lecture, and only an overview lecture. Actually, I expect to finish this and the next lecture today, next handout today, because these are very much overview, not too much into depth, and we really need to reserve time for things in depth as we go into more mathematical stuff later on. So this one is basically giving you ideas of the concepts, what are the standards, architecture, and then some of the attacks, services, and mechanisms. So first of all, some of the organizations that you may already be familiar with if you have taken networking course before are IETF, then ITUT, and ISO. These are networking standards organizations, and actually ISO is not just for networking, ISO is for everything, ITUT is for networking. So these are networking organizations, they work on security as well. But then there is one more called NIST. NIST is the National Institute of Standards and Technology. Previously it was called NBS, National Bureau of Standards or something. And so they work on security quite a bit. And so we will be talking about standards today, mostly one from ITU. But throughout the course, you will see things coming from these different places, and you may just want to visit them, like IETF or IETF.org, ITUT.in or ISO.org, and see what is there, because when you do the project, it will be important for you to go through the organization as to what they have done and what they are doing, right? And NIST is the one that actually designs all the security standards which are used in business in the United States, such as you may have heard of DES, DES, or AES, and so on and so forth. So those all. Alright, so what is security? If you want to remember what is security, the main thing you have to remember is, not very good. CIA. Anytime you remember security, you want to remember CIA, right? And CIA stands for, CIA stands for confidentiality, integrity, and availability. Those are the three main things. But last thing, it turns out, confidentiality means that you want to make sure that nobody can read the information, right? And how can you make sure that nobody reads the information? Encryption. Okay, but to maintain confidentiality, you need encryption, which is cryptography, but you also need access control, in the sense that nobody can get in where the information is not secure. The information might be secured inside a computer where it is not encrypted. Once on the network it is encrypted, but if somebody can get to the computer, then encryption doesn't help, right? So access control is part of that. Integrity. Integrity means nobody can change the information. Right? If you sent X and somebody changes it to Y, that would be really damaging, particularly because all of this is going to be used in the war. Remember, most of the security development, as you go through chapter 2, which we are going to do today, happened because of the wars. Starting from wars 1,000 years ago to the wars, Second World War, First World War, and so on and so forth. That is what keeps security business up. Because we need to encrypt, we need to really fight with the other side, which is equally smart, right? So integrity means nobody can change. Otherwise, they could just change the information. You say start, and they might say stop, and that's done, right? So that's not very good. So integrity is important. No change in the content, in the source, and so on and so forth. So we need to be able to not only prevent people from changing, but also we need to be able to detect that people have changed the information. Third thing is availability. Availability has to do with that people who need to have the information should have the information. Right? We talked about people who do not need to have information, they should not have it. So that is access control. But the people who should have the information, they should not be denied the information. That is availability. So denial of service attacks, which most of you know, DOS attacks, is where somebody makes the system so busy that real people cannot get into it. I mean, the real users cannot get into it. That is a DOS attack. Right? And so the idea is that we really need to make sure that we have some mechanism so that denial of service attacks cannot happen. So that is the summary. CIA. Security has three components: confidentiality, integrity, and availability. But it turns out it's not complete story. If we really wanted to do complete story, then A should stand for two more things. And I have added this line today in the hand. It's not in your handout. So I just put that in red so you know that this is information which was added later. But basically A can stand for availability, of course, but it can also stand for authenticity and accountability. So authenticity has to make sure that we can authenticate you. I mean, which could in some sense come into access control, but there are other places where we want to authenticate, such as if the information comes to me, I want to make sure that it came from you and not from somebody else. So that is not access control. That is just authentication. Second thing is accountability. So suppose you send me a message and then you say, well, I didn't send it. Then I have to have some way of proving that no, it is you who sent it. Right? So I can hold you accountable for your action. So that is not reflected in these three terms as it is, CIA. So A has to be extended to mean either availability, authenticity, or accountability. Or mean all three actually. So that is the summary of things. So 5 things then basically: confidentiality, integrity, availability, authenticity, and accountability. That doesn't stand for a very good acronym, so we leave it to CIA, right? Rather than CIA. All right. Any question or comment on that? So we move on to then standards. So there is one standard called ITU X800. In fact, I was just reading the standard and maybe I can show it to you. It's right here. I don't know if you can see it. And these standards actually are available to anyone. I think they're available to anyone. I mean, previously we used to pay for them every year. Then they have made it free, I think. You know, I'm not sure, but I have all the standards from ITUT, because if you work on networking, you need to have all these standards. So this is a standard X800, security architecture for OSI, Open System Interconnection. So everybody knows OSI, right? 7-layer model. That came from ISO. So one thing about ITU standards is they always start with a letter like A, B, C, D, E, F, G, H, all the way to X and Y and Z. So this is X series of standards. And then they have a number following that, X.800. Another X standard. Anybody remember another X standard? X dot something which is very popular. X11. Well, there might be a number X11, but I'm not very familiar with that, so it's not very popular. But X25. X25, right? X.25. And so this is X.800. All the series have some relationship. So X.25 was telecommunication, something. So this is somehow related to that. But anyway, that's not the key. The key is it's very small standard. It is total. Totally standard at 2000. I really think. Even a standard is now maybe like 4 or 5,000. Even if everybody don't know how much technology goes behind it, it's very, very thick standard. X800. What it does is it defines basically some terms, concepts, and we will just do that concepts. So it's an overview. It's a really tutorialistic standard in that matter. It doesn't really set any direction, and it just says what is meant by mechanisms, what is meant by security, and so on and so forth. So we will just define that. So according to that, there are three things that we need to know. There are security attacks, there are security mechanisms, there are security services. Alright, and we will define them one by one. But security attacks, we all know what they are. And like denial of service attack is a security attack. Somebody listening to your information is, somebody basically, changing information is an attack. But two terms which we have to know are different, or attack and threat. So attack means somebody really doing something. Threat means not really doing, but you're being aware of that this is possible. So right now we are under security threat. Right? Nobody attacked this room, but we are under threat because somebody can attack the room. Right? So threat is simply a warning, whereas real attack is something that you have to take action right away. Threat is something that you really have to take action, some precautionary action, so that you don't get into trouble. So this is actually true for all the emergency situations. For example, when you get a storm warning, sometimes there are two different things: a storm warning and storm. I'm not getting the time. So, watch. Right. So when you get a storm watch, that is simply a threat. Actually, that storm warning is a threat too, but maybe it is a level which is different. Storm watch means you can be, it's not really happening. It's just possible to happen. Whereas warning means just get into the basement. And so similarly here for security attacks and threats, if you are a security manager, you have to be aware of all the threats and then take action for them before they happen. Whereas security attack is something that you have to be really at the office, and changing things and fixing things right there. Okay? Alright. So attacks are of two kinds: passive and active. Passive means they really don't, you cannot even see them. Alright, passive means they're not doing anything actively to your information, they're not changing anything, so they might just be reading something. They might just be listening. When somebody is listening to your conversation, that is passive because they're not changing the conversation, but this is one of the violation of the things that we talked about earlier, and it's violation of what? CIA, remember, Confidential, they might be just able to decrypt it, somehow. We don't know that, right? So we don't want them to be reading. So this is passive, and this is kind of difficult to check, right? Or difficult to find out. On the other hand, active attack means that they might be changing something. And this is easier to find out, but it is more damaging. So again, there is a red line here, which is I added just today. Basically, they could be doing one of the 5 things here. This is just an example, this is not a complete list. They could be acting that, I am Bob, even though it is not Bob, but it is getting all the information from Bob and then sending some message here, which is different, and acting like Bob. Replay. They could record the information and then play it again later on. Right? So they could record as to what is done to get access and then just replay those messages. For example, password. They could just record the password and if it isn't clear, and then use it again. Modify. They could change the information and then send it. Our denial of service is that they could actively create so much load that this person cannot get in. Right? So that is an active attack. So now you understand the difference between threat and attack, and then passive and the active attacks. Now, security services is a term which is used for what we called CIA earlier, but now it is more detailed. So X800 really lists these services. There are 6 of them. Authentication, making sure that you are what you say you are. Access control, making sure that you only get to the information that you are authorized for. So even if they know even if they know that I'm Raj Jain and I'm Professor Bashu, but I'm not supposed to see the salary of people who are higher than me, let's say dean salary, I don't know, right? So that I'm not authorized for that. So authentication is one way of making sure that person is the person that is staying, but authorization is next level there. Is this person authorized to get this? So that is the assessment. Then confidentiality, that basically we talked about. Integrity, we talked about. Non-repudiation, we said that before accountability, but that is what it is. Non-repudiation means that you cannot change what it is, and you cannot deny what it is. So we can prove that you signed it. So for example, a lot of time you sign on the internet, right? Now, there are things nowadays, you can take a PDF document and you can sign it digitally, right? And you can send it to a lawyer. The lawyer will accept it, and then later on, 2 years from now, no, I didn't sign that piece of paper. Then nowadays, the digital signature is so strong that they can go to the court and say, no, it's this person who signed it, and nobody else will. It's like previously in the old days, they used to then they have signatures, nobody can write the same handwriting, and nowadays it is digital signature. So the digital signature, we'll talk about that too later in the course. So the digital signature is what we call non-repudiation, is one of the things that you can do. And availability, obviously we talked about. Any question about these 6 services? Okay, so the mechanisms, so these are the things that we need, 6 things we need, but what are the techniques to do those? Each service is a combination of different mechanisms. And so we'll talk about those mechanisms. For example, cryptography. Cryptography is service is confidentiality. For that we need cryptography. Right? Cryptography might be used for some other services. For example, cryptography might be used for non-repudiation. Who knows? Right? So we have to distinguish between the services themselves, which require a number of techniques, and the techniques themselves, which can be used in number of services. So the relationship between services and techniques or mechanisms is many to many. Right? Each mechanism can be used by many services, and each service requires many mechanisms. All right, so let's talk about mechanisms. So these are some of the mechanisms. Encipherment, that is encryption, digital signature, signing, access control, data integrity, authentication, exchange, traffic padding, routing control, notarization. All of this we'll talk about later on in the class, but these are all the techniques. Then there are, and each of these apply to a particular protocol layer. So the book actually distinguishes between a specific security mechanism and the one that is basically all layers. And so those are security labels, event detection, audit trails, and security recovery. So audit trails is simply keep a log of the system. Right? That is not related to a particular layer. That applies to application layer, transport layer, and it may not even apply to a particular service. We just want to keep a log of everything. Right? So those are pervasive as opposed to the specific. So these are all the mechanisms. So everybody understands the difference between mechanisms and services. If you have a question right now, ask. If you're not sure what is a mechanism, what is a service. Okay. Here is a more clear direction. So these are the services, and these are the mechanisms. So for example, for authentication, you might use encryption and digital signature and some authentication exchange. Whereas for confidentiality, you might use encryption and routing control. Just to make sure that, see here thing, suppose you have your data and it goes through Russia. maybe I mean, just pick any country, it doesn't really matter. And so you may not feel that secure because the route is wrong, right? So you part of confidentiality. And there is another reason to actually, when I read the next line, traffic flow confidentiality, is that some information can be obtained simply by knowing that A is talking to B. That's all. I don't need to know what they are talking, but A is talking to B is important for me. Alright, so that is breach of confidentiality. Second thing is some information can be obtained by finding out how many packets were sent between A and B, just counting. Alright? If 2,000 messages go between US and Iraq today, what will happen? Iraqis are watching, or some people are watching. Something is going to happen tomorrow. Right? So that's the kind of thing is, they don't understand what the message is, but just the count is important. So that's why this routing control is important, because the routers can just count the packets that were sent from A to B, and they don't need to see the information. And so anyway, so now to be clear that there are many services, and then there are many mechanisms, and each service uses many mechanisms that can be used in the service. Okay. So again, following on next page number 9. Basically, this is the picture of the security system. You have a message. First, you have to somehow change it so that it becomes a secure message. Generally, that means encryption. Then you send it to a channel, which is your routing control or whatever. And at the other side, the secure message has to become a plain message again. So there is a sender, there is a recipient, and there could be two other people. One is a trusted third party. And the reason you need the trusted third party is because there is some secret that you need to share. So both of us should have the same key. If I am sending to you, both of us should have the same secret key. So how do we get it? We need the third party to tell it to both of us. Because I don't know you and you don't know me, but both of us are known to Vashu, and Vashu says to you that, well, here's the key for talking to Raj, and they do the same thing to me, that here's the key to talking to this student. Then we both somehow trust Vashu, and we can start using that secret. And then the fourth person is the opponent. And they might have some information. Actually, it is not shown here, but they might, basically, ideally they should not have any of this information, but that's where we have to protect. So there are four players: sender, recipient, trusted third party, and the opponent. And then we need four different things. We need an algorithm for security transformation. We need to decide how to do the encryption or however transform it. Secret key generation. We need to generate a key that can be used for this encryption. We need to distribute that information. We need to get that around. So this trusted third party was assumed to be able to generate the key and give it to us. And then the protocol for sharing the secret information. And somehow that has to come to us. Both this communication as well as that communication. And so actually all of these are just preview of what is coming. So we will talk about algorithms for security transformation encryption quite a bit. We will talk about key generation, how do we generate a key. We will talk about how we share the secret, and so on and so forth. There is one aspect which is special, and that is the access control. If you want to use your network and you don't want anybody to be able to get to it, that's a slightly different picture than the previous one. In this case, there is a channel through which, there is a door through which people can come into your organization, which is in your network, but you don't want the other people to be, opponent to be able to get in. Right? The opponent could be a human or could be a software. And so you don't want to, so you just put this firewall or gatekeeper function. And then you need to do some of the things which are very similar to the previous one, authentication and so on and so forth, monitoring. So basically you want to make sure that only authenticated user can get in. So that is a model which somehow was not covered by this picture, so they just added that picture. So that's all about X800. Alright? That brings us to the end of this lecture. And 5 things to remember. 5 key things to remember. First thing to remember is that there are many standards organizations, and the 4 key ones are NIST, IETF, ITU, and ISO. Those of us who are in networking business know them by heart. We go there every day for one reason or the other, because that is where the latest things are happening. Second thing is that CIA is the keyword that security, and here C stands for confidentiality, I for integrity, A for 3 different things we talked about, availability, and what else? Anybody remember the other 2? Yeah, authentication and accountability, right? Non-repudiation, all right. And then X800 is the architecture which talks about attacks, services, and mechanisms. There are active attacks and passive attacks. And then the services are, other things that we talked about, and many different mechanisms. All right. That finishes that. Then we have the lab homework 2. If you have the handout from the last time, please discard that page. We gave you a new page this time. Just throw it away, because if your thing says here it's real instead of Wireshark, then you have the old page. Just discard that. This page is new, and you need this correct page. So to avoid any any confusion. All right. So these are the three programs that you will experiment with this week. Wireshark is a very important program, and you should really experiment with it on your computer if you can. It lets you see all the traffic on the network. In the old days, you could really see everybody's traffic even going between B and C when you are A. Today you cannot see that because the switches are now designed differently than before. In the old days, all the traffic was seen by everybody, but now the switches are designed so that port A can see only A's traffic. But so with Wireshark today, you will be able to see at least traffic coming to you and going to you. Yeah. 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 Then you can see. Yeah. Then you can see. So yeah, some people can come and replace your current new switch with an old hub, and you won't know any difference, and they will be able to see everything. Many of the new switches provide an option, monitoring port, where you can attach yourself and see everything. So you should know that. And that's their privilege. Because you sign on the dotted line to get so many dollars a month, you can boss me everything. So, anyway, Wireshark is one that allows you to do that, and there's another tool which is coming next week, but Wireshark this week. And you can download it from here. Advanced Port Scanner is next tool which lets you see what ports are open in what computer. Everybody knows what is a port. That's why you need to know all about networking. Some of you said, well, I didn't know networking, I don't know networking, but I will take it at the same time. If you take it now, you don't know what is port, because you haven't talked about port in CSE571-11-01. That will come 2 months from now. So you may be in the middle of the everybody knows what is port. Port 80 is for what? Yeah, HTTP port. So the thing is, port 21 is open, what does that mean? FTP, that you can go and FTP some information from that. There are FTP servers on that computer. So this will allow you to figure out what ports are open and what. LAN Surveyor. This is even bigger tool, which basically what it does is it allows you to see what computers are on the internet, on that network, on that switch. Actually, whole switch network, whole Ethernet. I mean, basically, so all the computers that are there, you can see them in the whole map by this tool. Now this tool is a shareware, these two are freeware. Shareware means if you install it, you can play with this for 30 days, which is good enough for this course. Alright, and that's probably the end of it. And then if you really need it and in your real job, you will pay real money. So that's it. It's not that big, but just want to let you know. So if you I mean recommend you have 2 or 3 computers. That you have, there's not much you can do. But if you have 2 or 3 computers, then basically if you have 2 computers connected to this switch, there are some of these things you can do. Alright. If you don't have it, then we have put 2 computers in our lab just for this purpose, so you can play with it. And those 2 computers are called CSE571. S is the server, and then we have a client C2. We have these 2 computers, and you can just do whatever with these 3 tools. And tools are also installed for you, and you can play with them in that lab. And so your job is to use the network circuit to show the map of all the hosts on your net. It doesn't really matter, and our net. Then you ping www.google.com to find this address, and this address could be different in every place, right? So you find the address and then start Wireshark, and then set capture option to filter by IP address to capture all the traffic to and from this address. So from Google's address, right? You capture all the packets, then you stop the Wireshark, and then submit the screen capture showing the packet seen. Now, there is one more step after this which I have deleted for you guys, but this step is to interpret those packets. If you have taken 473 here, then we teach you in the very first lecture what are the HTTP messages, get, port, this and that. And if you remember that, you can see all those messages right here in Wireshark. Alright, if you have not taken 473, you will probably, so I deleted that basically. There are not some of you have not taken 473 here. But you should be able to see the messages and make sense as to why this message went. What is this message doing? Alright, so you just do it, if you know it, then you can figure it out. And obviously this is very useful for security as well as for debugging anything that you are doing. Right? So that is yes, those are the 3 things. I skipped this one. Use advanced port scanner. So 1 to 3 hosts. And so you don't go and, if you go to our lab, there are many computers visible, and so just limit the address range. Basically, the way you limit to 1 or 3 hosts is that you just give the address range from this address to this address, and hopefully, if you give the whole 255, you will get maybe 100 more. If you select it for 10, maybe you will get 1 or 2 hosts. Right? So those are the 3 things. Any question about the lab? Yeah. Right. How are you going to security lab? All right. I'm going to come to that in a minute later on. Okay. After this recorded lecture is over. So that is the next. So right now, let me finish this recorded part. Security URLs. So since this is the first lecture in the course, we just want to tell you where all the information is available, and the book actually does this. Actually, this is all from the book. There are many places where security-related information is available, and again, you will find it useful when you go for the projects. So these are some of the things. IETF security area, for example, and the website Cryptography FAQ and the security page, and so on and so forth. So all of these places, you will find some additional information. We are not right now using it, but just for your information, I have put them here. Then there are news groups, and I don't even know if anybody sees news groups anymore. I don't see any more news groups, so this is more historical. Does anybody see any news groups at all? I think they're gone, but anyway, the book talks about the news groups, so I put them there. I think more recent information is this Google groups and LinkedIn groups. Now, Google groups is where the action is. So if somebody has a question or something, they go to Google groups, and that is where they find, right? And then in LinkedIn, what is LinkedIn? Anybody know LinkedIn? Some of you know. So that is a professional organization, basically where everybody who is working in the real world is a member of, you can be a member of too, and they make connections. So then there are groups, some people discussing security, some people discussing internet, some people discussing next generation. And there you see the real problems that the industry is facing. Alright? And so that is where I think is more realistic information. This old stuff is, I think, historical. So this stuff here, but basically this was in your handout, but this was not in the book.